Severe Weather Awareness Week continues with a short discussion on lightning. Did you know that there are about 25 million flashes of lightning every year? Each of those flashes is a potential killer, with an annual U.S. fatality rate of 54 persons and hundreds more injured. While the number of fatalities has decreased over the past 30 years, lightning continues to be one of the top storm-related killers in the United States. Lightning forms due to charge separation in a parent thunderstorm cloud. This charge separation occurs due to air movement and the frictional interaction between the various frozen and liquid precipitation within the storm cloud. Lightning is in essence a giant spark of electricity in the atmosphere, or between the atmosphere and the ground. The two primary types of lightning are intracloud, whereby the lightning is contained within the cloud, and cloud to ground, in which lightning bolt travels from storm cloud directly to an object on the ground. As mentioned earlier, charge separation within the storm cloud is the primary mechanism through which lightning forms. In a typical storm cloud, positive charge becomes concentrated within the upper reaches of the cloud, where precipitation is more frozen in character. A corresponding negative charge then develops towards the middle and lower portions of the cloud. Air is generally a poor conductor of electricity, normally preventing charges from moving freely through the atmosphere. However, if the charge difference between positive and negative parts of the cloud, or if the charge difference between the cloud and the ground becomes too large, the insulating capacity of the air starts to break down and the air starts to ionize. This breakdown occurs on a molecular level and allows negative charges to start moving more freely in the form of a stepped leader. Stepped leaders generally move downward from the cloud or upward from very tall objects on the ground. Leaders can be negatively charged or positively charged. An estimated 90% of the cloud-to-ground lightning flashes originate from negatively charged leaders that develop downward from the cloud, while about 10% of the cloud-to-ground lightning flashes originate from positively charged leaders that develop downward from the cloud. Lightning flashes originating from upward developing leaders are relatively rare. During the development of the stepped leader, the positive charge on the ground increases. As the branches of the stepped leader approach the ground, the electrical forces between the leader tips and the tops of tall objects on the ground also continues to increase. Eventually, these forces cause the air above the taller objects to become more conductive and ionize. As this happens, the negative charge starts moving from the air to the taller objects and into the ground. As a result of the negative charge moving toward the ground, the channel of air directly above the taller objects becomes positively charged. This is usually referred to as an upward streamer. Eventually, the negatively charged, downward-moving stepped leader makes contact with one of the upward-developing positive streamers. When this contact is made, the lightning channel is complete and charges can flow rapidly from the cloud toward the ground. It takes only a fraction of a second to go from the stepped leader initiation to the final connection. The return stroke is a very bright, visible flash that we see as lightning, caused by the rapid discharge of electricity. Once the stepped leader makes contact with a streamer, the negative charge that has accumulated along the leader channel flows rapidly to the ground. The movement of the charge starts at the point of contact and rapidly works its way upward as charge is drained from the channel. Although the visible flash is associated with the rapid movement of charge downward, the actual flash propagates upward throughout the channel as the negative charge starts moving toward the ground. There are a number of lightning myths that have been around for a number of years and are simply not true. Here are a few. Myth: lightning doesn't strike the same place twice. Fact: lightning often strikes the same place repeatedly, especially if it's a tall, pointy, isolated object. The Empire State Building is hit nearly 100 times a year. Myth: if trapped outside and lightning is about to strike, I should lie flat on the ground. Fact: lying flat increases your chance of being affected by potentially deadly ground current. If you're caught outside in a thunderstorm, you keep moving toward a safe shelter or assume the lightning safety position if shelter is unavailable. Myth: rubber tires on a car protect you from lightning by insulating you from the ground. Fact: most cars are safe from lightning, but it is the metal roof and metal sides that protect you, not the rubber tires. Remember, convertibles, motorcycles, bicycles, open-shelled outdoor recreational vehicles, and cars with fiberglass shells offer no protection from lightning. When lightning strikes a vehicle, it goes through the metal frame and into the ground. Lightning poses many dangers, not the least of which is the danger to personal safety. The good news is that the overall survival rate from lightning strikes is relatively high, around 90%. However, many of those struck receive serious and sometimes long-term debilitating injuries, including severe burns and nerve damage. Other safety risks posed by lightning include damage to electrical equipment and the potential to ignite fires in structures which are struck. Thank you for viewing this presentation on lightning. For more information, visit us on the web at www.weather.gov/Burlington, like us on Facebook, or follow us on Twitter.